Hello guys, welcome to 80% Tech View, another tutorial. In this tutorial, I'll show you guys the architectural design for what? The architectural design for your storage connections and also iSCSI configuration on the VMware ESXi host side. So there is a multiple way you can connect your ESXi host with your SAN storage. So in this tutorial, I'll just explain, but I'm not going to show you the physical connections configurations. So the configuration I'll show you in another video, but this one I'm gonna just explain like how you can make the design, like how what should be the architectural design. So how you can, that's actually basically your plan, how you can implement, right? So for implementation, I'm going to share my documents. So that's how you guys will understand actually how you want it. So I'm going to share. Okay, 1 second. So, and I believe you guys are able to see it. So this is what I have. Now I'll share these documents link on the description box. So this is very important to understand before you do something. So what I want to show you guys this one, because if you want to work as an infrastructure system engineer, in that case you should have some engineering knowledge, how you can configure them, and before you configure you should have some pre-plan, and that's the pre-plan. So you should have some design, and which is called architectural design. So think about, you have a Unity SAN storage. This is a Dell EMC Unity storage system. This is the front side of the storage. And this is the back side of the storage. I'm going to make it a little bit bigger, so that's how you'll be able to see in a better view. Just 1 second. Okay, let's do it like this way. Okay, so this is the back side of your storage. So this is the front side of the storage, and this is the back side of the storage. So this is the Unity SAN storage. It's iSCSI SAN storage. So if you have that kind of storage, or before you have that kind of storage, if your organization tell you to order storage systems plus design the total complete infrastructure, so if how you gonna design it, so you have to have some knowledge. So, and also like connection is, you can connect anywhere, it can be connected, and you can establish the connection between your storage and your ESXi. That's not an issue. It's pretty simple and easy. But the thing is, how you can maintain high level standard. The standard is very important. So you have to think in each and every aspect, like how you can provide redundancy, network wise, storage wise, network switch wise, your server side, your server network port wise. So everything you have to consider. That's why you need to know actually how many port you have on your storage, how that you're gonna connect them. So usually the Unity storage has a SPA and SPB. That's the 2 unit. One storage server comes with 2 unit, SPA and SPB. Internally, it has a cluster system. So if SPA is completely down, still your storage system will be up because SPB is up. Or if your SPB is down, still your SPA is up. So that's how storage is designed. It's designed by your manufacturer, that means by Dell EMC. So Dell EMC is ensuring you that you have the redundancy. Now it's your turn. How are you going to connect them in your environment? So in your environment, SPA has 4 connections. You see here? In here, you have 4 connections. Port 0, port 1, 2, 3. So SPA has 4. Not only 4, it has total 8 actually. So you don't need to add all of them. 4, it's gonna make total 8 connection. So if one you lose, you have another 7. If you lose 2, you have another 6. If you lose 3, you have another 5. So it's a huge redundancy connections. So for this one, how are you gonna connect them on your switch side? So I'm going to show you actually on the switch side. So say for example, from your SPB, you are planning to connect, you are planning to utilize only 4 port. You're gonna connect this 4 port from SPB, you're gonna connect with your switch, network switch. But network switch side, maybe you don't have your control because it's completely managed by your network team. But at least your network team will give you some information. So you have to ask them, hey, I want total 8 connections, 8 network drop, but 4 of them will go one switch and another 4 of them will go different switch. Not only that, I have switch SPA and SPB 2 unit, and from 1 unit, like from SPB, I have 4 network drops, but all four will not gonna go in the same switch. So from SPB, two of them is going switch A. Just an example, switch A. So you have to explain it to your network team, and then they will suggest you, okay, we have switch A, B, C, D, whatever, right? They wanna give you 2 switch, and you can just distribute your connections to those 2 switch. So from SPB, I choose the first port to connect to switch number A, and then the third port, switch number B. And then the rest 2 port, where I connect, you see, the second and fourth from SPB, I connect it on switch number Z. You see here, switch number Z. So these 2 connections is done. Now SPB, or the first unit, think about, through the manufacturer, you have the redundancy, right? In here. Now you are providing another redundancy on the network level. You are providing from your server side as a system engineer, right? So 2 connection is from switch A. So if something goes wrong with the switch A, automatically it's gonna, you have another 2 connections. So it's SPB not gonna be down. If your one switch is down, your SPB is not gonna down. Still your SPB has another 2 connections. And that 2 connections is coming from switch number Z. Or think about switch Z is down. Your SPB is down? No, because your SPB has another active connection from switch A. So that means you are providing, by your configuration, you are providing network level redundancy. So this is the second layer of redundancy, right? And the third layer, the network team, they have switch A and switch B a cluster setup. So if switch A down, all the switch A's connections will be moved to switch B. It's the network side redundancy. So you are getting third layer of redundancy. So that's the plan. Same thing from SPA. From SPA, first and third connect to switch Z, and second and fourth connection is connect to switch A. So if something goes wrong switch A, still you have another 2. Is it make sense? Yes. I think it makes sense, right? So there is a multiple redundancy, multiple steps of redundancy. So Dell is providing you the unit-wise redundancy, SPA and SPB, and you are providing network side-wise redundancy. So I discussed about third layer, right? Third layer of redundancy. And the fourth layer of redundancy, the fourth layer. What is the fourth layer? So when you configure the IP address, make sure for your what is called these 2 connections, right? It doesn't matter where it goes, but make sure at least your 2 of the connection from your SPA and 2 of the connection from your SPB is connecting with a VLAN 210 or something, whatever it VLAN 210 is. I just put it in as an example. Maybe from your case it's going to be VLAN 640 or 220 or 110 or only 10. It's up to you or your organization, but just an example. 210. So VLAN 210 IP, that means 10.15.210 dot, say for example, it's a 24 subnet, right? So say for example, is in the last one is like say 11, and then 12, 13, 14 like this, or maybe you can go up to 253, up to 253, right? So usable IP. So for these connections, the green one, you see the green cables. So these connections, 4 connections, you can use VLAN 10, and for or the purple connections, right? So purple connection, 2 connections coming from SPB, and 2 of them is coming from SPA. And these 4 connections, if you use the different VLAN, say 215, the first 4 you connect with VLAN 210. Now this is 215. So the completely different subnet. So that's the 4th layer of redundancy. Why? Because you may never know from the network side, because you don't need to have that much idea about how the VLAN is configured on the network side. It's all about network team decision and their plan, right? So you don't know. But if you put all 8 connections in one VLAN, what's going to be happen? For some reason, if they change any kind of firewall policy or any kind of policy they change it to this VLAN, then all of the connection will be down. That means your storage will be down. Your switch is okay, both switch is okay, everything is okay, but you used only one VLAN for your total 8 connections. And if for some reason your VLAN is affected, that means your entire storage will be affected. That's why you should use 2 different VLAN. Now I think it makes sense, right? So that's what we need to plan. Now go to your ESXi side. How are you gonna connect your SAN storage? So your SAN storage, your storage is now connecting with a multiple layer of redundancy with your network connection, network switch. Now is the time to connect your ESXi host with your network switch, and how you configure, how you confirm the connection with your storage. So make sure your server should have at least minimum of 8 network port. Out of 8, one of them is iDRAC connection. One of them is the iDRAC connection, and then 7 left, right? So out of 7, now 2 of them you want to use for your host management. That means you are providing the redundancy here. If this one goes down, then this one will be up, right? This way. So that means now how many left? Total 8, right? Out of 8, first one is for your remote management, which is iDRAC, ILO, or IPMI. Any kind of server. I just chose here a Dell server because Dell use iDRAC, right? So any kind of remote management, it can be Dell EMC, like Dell PowerEdge iDRAC, or maybe for HP is ILO, for Cisco is IPMI or ILO, Cisco UCS server. So anyway, when you purchase a server, you have to make a plan, right? So how many network port you require? So, and also 8 port, minimum 8 port is required, including remote management. If you have more than that, that's fine. That's completely okay. No issues. But another requirement on your server, you're supposed to have the iDRAC is all the time is 1 gig connection, most of the time. And management is not required 10 gig. So you can have like management, you can have 1 gig connections, that's fine. Maybe these 2 port can be inbuilt on the motherboard, and the other, so and the other, how many ports? So 1 and 2, 3 already gone out of 8, and then 5 left, right? So other five connections, maybe on 10 gig connections recommended. But if it is 1 gig, that's not an issue, but recommended is 10 gig. Okay, so 5 left, right? Out of 5, 2 of them, you see here, I have 2 NIC card. I have 2 NIC card. Why I used 2? Why I didn't use these 2 for the iSCSI? Because look like this 4 port is belongs to one physical NIC card. So if I use these 2 port together for my iSCSI connection, I'm providing the iSCSI redundancy because I have 2 connections, right? If one connection is, if I lose one connection, still I have another connection, right? That's true. That's true that you are providing network redundancy, but what gonna be happen if your entire NIC card is down? That means your iSCSI connection is gone, right? So that's why make sure you have different NIC card with different port. So it's better to have one NIC card with 2 port. That's the best suggestion. One NIC card, physical NIC card with 2 port. That's how we can have multiple NIC card with different port. So if NIC card fail, but if you have one NIC card with 4 port, but for some reason the physical NIC is down, that means if physical NIC is bad, that means your all 4 connection is bad. That's why I use one port from this physical NIC card and another port from the other NIC card. So that means I have 2 separate connections for my iSCSI. It's a redundancy, right? Plus from 2 different NIC card. That's also another kind of redundancy, right? If NIC card is bad, then I don't need to be worried, right? So now you understand on your server side, but how you're gonna connect on the switch side. So if you look at here, from my server, one connection goes to switch A, and then from my server number B, from this port, first port is going to be switch number A, and the same thing from third server is going to here, right? And then from the bottom NIC card, the first port is going to where? Switch Z. That means from all 3, the bottom from the first NIC card, from the first port is going to switch Z. Now that means what? Your connection from all 3 servers, one port is connected on switch A and on switch Z. So switch side network team, they have redundancy, they have cluster. So you have 2 layers of redundancy which is called available from the network switch side, from the network team side, and from your side you have 2 different NIC, so one kind of redundancy, 2 different connections, then another layer of redundancy, right? So you're not going to losing. Plus, why for iSCSI I'm using 2 connections? iSCSI only support one physical NIC card, not multiple NIC card. That's one of the requirement. You have to remember, iSCSI support only one physical NIC. But for the data, like whenever we're gonna configure network, you're gonna understand better way. So for the other 2, 3 we have left here, right? Other 3 left here, right? So out of 3, maybe one of them we're gonna configure for vMotion. If you lose the vMotion connection, your system not gonna be down. But if you lose the iSCSI connection, your system will be down. So that's why for vMotion, most of the company, they are not worried about ensuring the redundancy for the vMotion. But if you have available port, you can take one port from here, another port from here, and you can configure vMotion. Then 2 left, right? 1 and 2 and 1 and 2, right? So that means total 4 port left on the one server. And that 4 port you can configure for your VM traffic, virtual machine traffic. So for the virtual machine traffic configuration, one switch can have multiple NIC, but one adapter can have multiple NIC. But for iSCSI cell, is only one. iSCSI 7 is only one NIC card support, only one physical NIC support. So that's why I use two NIC cards separately with two separate cable. Not only that, from two different NIC card. Not only that, I use two different, if you can look at here, two different VLAN. VLAN 250 is connected with the top first port of the first NIC card. You see all the cables from the first is using VLAN 250. That means IP address will be all 10.15.250. something, right? For all three. This is how it's connected with your iSCSI storage. That's how your iSCSI, your storage connect with your ESXi environment, and it's connecting through the switch, network switch, right? And then from the bottom connections is connected with the switch Z, right? And that one I use different subnet 240. So that's how another layer of redundancy. Why another layer of redundancy with the different VLAN? Because if same thing, network team do some kind of maintenance or they change any kind of policy, it's going to affect. If you use, like, say for example, your cable is separate, but you use only one VLAN for these three connections, and also for these three connections you use the same VLAN, same VLAN range IP. In that case, if they change any kind of policy, it's going to affect all of your connections again. So your storage is okay, your switch is okay, your server is okay, but your system is down because you use same VLAN for your iSCSI connection. So your system will be down. That's why you should use two different VLAN. So I believe I am able to explain. This is the design. So if you don't understand, or if you think like it's too much complicated, just go with first, try to understand one side, and then go for the other side, only the iSCSI connections, and then maybe you can go for the Hydra connections and go for the management connections, right? This is where you can go. And I will share these documents with the description box. So if you guys have any question, you can ask them on the comments. And that's all. And another video, I'll show you how actually you configure with like this way, how you can configure your iSCSI. And I think that's all for now. And if you're new in my channel, please subscribe my channel. And if you think this video is helpful, please give a big thumbs up and also make some comments, because your comments encourage me a lot to make more video for you guys. Thank you. Thanks for watching, and I'll see you in another video.